From this video, we solve a few packing optimization problems. This one is known as Knapsack problem. Okay, so let's imagine we are moving the house. We hide a truck. Now the truck can have a maximum weight of 850 kgs, let's say. Okay, 850 kgs. Now we have a number of items. For example, let me just print. Okay, so we have 50 items in our house, and the truck can have a maximum capacity of 850 kg. Now the weights of 50 items is this. Okay, for example, the first item is 7 kg. The second item is so light that its weight is negligible, and the third item, it has a weight of 30 kg. Okay, and then for each item we have the corresponding the price, right? For example, the first item with 7 kg weight, its value or it will cost us $360. Okay, the second item, which is the lightweight, it cost us $83. Okay, and yeah, so for the 50 items we have the weights, we have the value or the cost. Okay, and then in the truck we can only pack the total weight of 850 kg. Okay, but if you look at the total weight of the 50 items we have, it's 1874, but unfortunately we can pack only 850 kg. Okay, so let's imagine we want to make only one trip, right? We want to utilize the maximum capacity, but at the same time we want to maximize the values of the items we ship, right? All right, so the total value of our items is $8,604. Okay, I hope the problem is clear. It's very simple. We are moving a house, we have a truck, and the truck maximum capacity is 850 kg. Okay, we have total 50 items at our house, and here we have the weights of all those 50 items. Here we have the price of all those 50 items. Now, which items should we take so that the total weights of the items is less than 850 or at most equal to 850, but at the same time the value of those items which we are taking is as much as possible or maximum possible. Okay, that's the problem. Now it's a easy problem in terms of defining it, because all we need is just these three variables: the values, weights, and the capacities. Now notice that the weights is a list of lists. I looked at the document why we need this as a list of lists. I did not find anything, but maybe if we have some additional constraints, maybe we can have some weightage or some priority items which may defined using the other elements in the list, right? But for the time being, let's say all items are equal priority, are only defined by the weight, the value, or the price of the items. Okay, all right, so we simply define this knapsack solver. Okay, and then we initialize the solver with these three variables. Okay, the values, weights, and the capacities. Okay, the values, weights, and the capacities, and then we trigger the optimization, right? All right, then here we just define few empty lists, and the total weight which we are actually taking to 0, and the solver, it will return the total weight or the computed value, sorry, total value. Okay, so the total value of the items we are taking is $7,534, whereas we have items worth 8,600. So roughly unfortunately we have to leave about $1,100 worth of items. Okay, just $1,100 worth of item, and the total weight we are taking is 850, which is great because we are maxing out. So we are transporting the maximum weight allowed within this truck or container. Okay, so that's good. We have maxed out our weight, and at the same time we have maxed out or we are taking the maximum value possible. Okay, so out of these $8,600 worth of items, we are able to take 7,500 worth of items. So here what we are doing is we are looping over all the values, or we are looping over the length of the items we have, which is 50 items. Okay, so next we want to see which items we are able to take. We want to make a sense of which ones we are taking, why we are taking, which ones we are not taking, why we are not taking, right? So what we are doing is we are going over all the items one by one and then checking if the item is contained in the best solution, meaning that item we are taking with us. Okay, if we are taking with us, then we are appending the item to our packed items, and then we are getting its weight. Because weights is a two-dimension or list of lists, we have this index 0, and then we are computing the total weight. Okay, all right, so we have already seen these ones. We are taking a total value of $7,500 and the total weight is 850. Right, so these are the items we are taking. That's the index. So 0, 1, we are not taking item number 2, and these are the corresponding weights. Okay, now let's flip it. So instead of checking if an item is in the best possible solution, this time we are checking which items are not in the best solution, meaning which items we are left behind, we are not taking. Let's see if that makes sense. Okay, so we are not taking items worth roughly 1000 kg, but more importantly, let's look at these two. Okay, missed items along with missed values. So this item, it weighs 30 kg, but its value is only $60. Okay, if you look at this one, it weighs 94 kg, its value is only $67. Okay, 94 kg, $67. If we go back here, we can see this 94 is probably the highest weight items in this list. It looks like, yes, it is the highest weight items, whereas its value is only $67. Okay, its value is only $67. Whereas if you look at this item, even though this weight is on the higher side, which is 80 kg, but this item worth a lot, right? This item worth $431. Okay, so it makes sense we are not taking this item because it's heavy, but it's cheap. Okay, it's heavy, but it's cheap. Now these items which weight 0, we should take them, right? Because it is not constraining us any capacity, right? So whatever be the value of these items, we should be taking these items because they are almost as if they are free, right? This one, this one, this one. For example, all these zeros, if you look, we have 3 items with zeros. So in these packed items, you can see 0, 0, 0. So we are taking all the 4 items which are weightless irrespective of its value. Okay, and looking at these two arrays, it makes sense that the items which are heavier but which are cheaper in value, we are not taking them. Okay, so it makes sense. All right, that's it for the video. Thank you very much.